So show of hands, who spent 80% of your revenue on token? Okay, everyone's very budget friendly. 40% cost on token. Anyone? Or just GPU, flat out GPU. You spend all the money on GPUs, not token. That'll be pretty cool too. So one of the things that, so again, my name is Carmen Li. You will see two companies here, one Silicon Data, one Compute Exchange. So I have a dual CEO role, founder CEO for Silicon Data, which is GPU index data company, Compute Exchange, which is about compute marketplaces. So you need GPU, please let me know. Please let Rob know sitting here. If you're looking for data, you can feel free to reach out to me as well. But we're gonna talk about token. So one of the things that we've been realizing is, while talking to customers and clients, there's a lot of things we're trying to figure out is, obviously today, most people here rent these GPU per GPU per hour. That's how your cost structure is. That's how you think about your costs going forward. You're forecasting based on GPUs. However, we do see a trend, even from data center sort of side, is people start charging by tokens. If you're a consumer or AI agentic flow, you usually charge your clients by $1 million token, either input token or output token cost. So we do think there's a lot of shifting going to be happening in terms of cost structure. So I don't think many people need the token cost 101, but would quickly touch on that. And the measuring observability is something that I do care deeply about, transparency and efficiency. Optimization playbooks. So at Silicon Data, we use a lot of AI workflows to generate our own products. So we have a lot of lessons learned, for better or worse, forecasting, hedging, pricing, and how we can help. So token in our world is very specific to LLM tokens. So we break down to input token, output tokens. And they can price very differently, depends on the model, open source model, closed source models you're using can differ from 1.1 ratio all the way to 1.10, 1.20 ratios. It's a hidden cost driver, so people know the infrastructure costs, the vector database, logging, monitoring, human costs, iterations all become your hidden cost drivers for your workflow. So the token data is interesting. So we keep track of GPU cost, which on demand costs, they do fluctuate up to 40% every day. Token is a little different. The cost is pretty static for the closed source models. For the open source models or open weights models, they do fluctuate based on where you are at, which infrastructure provider you're using, the time of a day, or you're batching or not. So that's kind of interesting. And then especially when new model comes out, what happened to the old legacy model, how the price is going to change for that. So the cost spikes, I don't know if the team experienced that. We experienced a few times. So one of the things that we've been trying is, one of the product we've been building called Silicon Sphere. So sometimes we use very large context window. So that's expensive, right? Even though every model have different context window sizes, if you max out that every single time, that definitely gets add up. New features always, introduce new hidden costs you might not know beforehand. Sometimes one power user come in, they just keep clicking through all the prompts and generate a lot of costs for you. And a reasoning model. So some models, they are more smaller model, not much reasoning, not much thinking token involved. Some model requires a lot of thinking, so the reasoning model overhead is pretty significant. And if you use a lot of applications, create a sort of a hallway, chatbot functions, can be costly as well. So the way we think about internally is cost per request. So every time someone, either a feature or a user inputting a request, we think about input token cost, output token cost, plus infrastructure overhead. So to really determine the unit economics. And the cost per user metric is also very interesting. Because we think about different users actually have different cost structure, depends on how you use your product. So we monitor cost per user, per seat, per team to understand the margin and the cost, and then see how each product will actually behave differently based on the user experiences. And then based on that, we figure out the feature level margins. So margin is very important to us. We don't want to pay 100% revenue to the model providers. So how do we calculate margins across different platforms? Imagine if you use 5 models in one chain of application, and then they all potentially different infrastructure. How do you keep track of the costs among all the 5 infrastructure providers? So one of the things that I encourage people to do is really logging. Log every call with every model, token count, latency, feature tag, account IDs for complete visibility. You might not know how to use the data right now, but I encourage all the logging if you can do it. Especially if you can have a unified key across all different platforms. So you can sort of tag everything correctly, same model, different infrastructure platforms. How do you group them together? You understand all the costs is actually attributed to one model, just different infrastructure platforms. Again, let's come to the strategic roll-ups by feature, by account, by model, by regions. You can see a lot of patterns very quickly. And proactive monitoring. So one of the things that we see is something's happening very quickly. How do we make sure we change the product quickly on the fly? Or how do we make sure that certain features don't run away from us, the certain costs? And then we do cross-team review. So the finance team, obviously they want to know the margins, the cost, the forecasting. The engineering team would love to know, hey, how can I get the next best models? And the product team is all about user adoption. So getting all three teams aligned is pretty strategic. So a few things we have done, I don't know what happened to this slides, but prompt learning. So basically, how do you strip away some of the taxes? How do you make sure the context is compressed and then maintain same level of quality? A lot of trials is really needed. And also make sure you set a budget for any tokens. Really be cautious about how much money you spend on each request. So based on some of the things we do, usually our process is, I always say, go for the best, go for the most expensive model. Let's just see if that works. And then later on, we'll be like, okay, that worked. Now, how can we make sure optimize the playbook, right? How can we divide the task into, this is summarization. We don't need thinking model, right? Let's do a really small models. It's probably more deterministic. Let's do that. And then the thinking model kicks in whenever thinking is involved. So how do you make sure you get in the intelligent routing of different tasks to different models? And also distill the large model behaving to smaller, more cost-effective models. I think that's really the key. I know in the Women's AI panel this morning, people talk about caching. I think that's a very hard problem. Well, our team is working on that as well. Think about how do we reduce the reprompting, the regenerating of tokens when it's not necessary. It's going to be very critical. Batching, right? If you don't need it right away, how do we make sure optimize basically the time you get your token back versus you want it now? Course guardrails, make sure you set up boundaries for certain workloads so you can cut things off when you don't need that. It's not always accurate, but at least the effort is there. This example of rack-based SaaS feature workflows that we try to figure out and really understand the monthly cost per queries and all the margins. Open source closed source model comparison. One of the things we notice is, just because it's open doesn't mean it's premium. Sorry, just because it's closed doesn't mean it's premium. If it's open doesn't mean it doesn't work well. So you have to keep trying different things. And then we break it down different tiers based on sort of the way we're thinking about different workflows. One of the things we also look at is when should you host on premise versus API calls. All things are pretty, self-explanatory. One thing we will point out is security is one of the bigger concerns of our products. The data is pretty sensitive. So we try to figure out, okay, how do we know that the third party will not use my prompting, my input tokens, my APIs, information for other reasons? I really can't be sure, right? I don't think there's an encryption a lot of times happen for those third party. So depends on your workflow, how sensitive things are, your option might be limited. Cost-wise, again, if it's API, it's higher per token. If it's on-premise, if you want to host yourself, maybe it should be cheaper at a scale. The upfront cost will be GPU, which is everyone here is here for. That's how compute exchange can help you. If it's API, it's no upfront cost. However, you are at the mercy of demand supply curve for some infrastructure providers. One of the things we're looking at is feature level forecasting. So a lot of people think, okay, how do we think about how much more GPU we need, how much token we should think about for budgeting for next year? I believe granularity is actually key. You can't really say, hey, my A product will need 20% more token next year. You really have to break down to, okay, what feature, right? What's input, how much input token you think gonna increase by, output token gonna increase by, what kind of user developer case sensitivity for your context window. There's a lot of granularity. So usually I believe if you break down into more granular level and then do feature specific forecasting and you add everything up, becomes a lot more science than like just sort of an art. And then you can tweak your inputs, which assumption is not right. Maybe a lot more use than you thought would be for feature A or product A versus it's just because of one user uses so much more thinking token, right? So it's more specified, and then you know exactly what a pinpoint is. And a few levers everyone here have: volume discounts. You can always talk to the model providers, infrastructure suppliers to talk about potential options. Multi-vendor strategy, always believe in make sure you have options. So usually open source models, open weights models give you the option, then closed source models. Compute hedging, there's ways you can hedge your compute costs if you're looking at compute directly. Again, other commodities have in mind is, purchasing, inventory management, forecasting practices. So pricing, so that's one thing we constantly think about. How do we price the product? So a lot of people think of usage-based. At least you should cover your cost. Shouldn't be 100% of your revenue goes to your cost. So the premium tier design is how you, if you longer context window, maybe you should charge a higher price premium, and then cost alignment. The way I think about my product is really based on how much we think alpha can really generate for clients. So we create something called Silicon Sphere, which I mentioned, generate a lot of insights for financial services firms. So for us, this is the amount of cost we think we're going to incur. Here are all the breakdowns. But our revenue is 100% not related to the cost. It's really based on alpha. Or it can be more usage-based metering. It really depends on product. Here's sort of an average level margin model that we're seeing. Every token, cost request, and how do you think about your price tiers? And I have 20 seconds left. So this is how we can help you: real-time monitoring, cost governance, predictive analytics, optimization engines. Talk to me if any of those interest to you, and I think that's it.